All right, this is 9.3 day one. 9.3 day one. Up at the top here, this is our toolbox for 9.3. We have x squared plus y squared is equal to r squared. Now, that's the equation of a circle, but we're going to use this relationship to go from Cartesian to polar. Then other tools we have at our disposal to go in between is x is the same as r cosine and y is the same as r times sine. And to find the angle, we would take the tangent of theta as y over x. Now, all four of these allows us to go between Cartesian and polar. So find the rectangular coordinates for each point with the given polar coordinates. This is the r, this is the theta. So the rectangular is going to be 4 times the cosine of pi over 6, and we go back to the unit circle where cosine is the x. 4 sine of pi over 6, and we know values for pi over 6. The cosine is square root of 3 over 2, and the sine is 1/2. So we end up with 2 square root of 3, 2 for the x and the y. Now, same thing here, but I just gave an example where we don't know anything about 20 degrees. So we have 6 cosine, 6 sine of negative 20, and then we're going to just plug these into the calculator. Now I'm going to make sure that the mode is in degrees for this one. And we have 6 cosine of negative 20, not that. And then 6 sine of negative 20. And we're going to round to 3 decimal places unless it says otherwise. So 5.638 and negative 2.052. Find two pairs of polar coordinates for each point with the given rectangular coordinates. Well, we need, this is an x and a y, we need an r and a theta. Well, how about this up here? X squared plus y squared is r squared. So r is equal to the square root of 9 plus 36. We're going to square the negative 3, square the 6. We're really doing the Pythagorean theorem. So r is equal to the square root of 45, which is 3 square root of 5. So we have the r, and now we need the theta. So we need the inverse tangent of y over x, negative 6 over 3. And so so we want the inverse tangent of negative 2. So inverse tangent of negative 2. And we can have negative values for this. It's just, find 2 pairs of, all right, so we need 2. So we can certainly have negative. Let's see, our r is 3 square root of 5 and negative 63.435. Let's get an idea of where that is. We have negative 3 and up here at 6. So let's see. Right there, and so negative 63 would not actually work with a positive r because we're down here, but our point is up here. So if we're going to use this negative 63.435, we're going to have to make that negative. All right. And then if we want to use a positive, then we're going to have to find out what this angle right here is. So we're going to have to add 180 to this negative 63. So plus 180. And now we can use 3 square root of 5, but then we have 116.4565 degrees, like that. Find 2 pairs of rectangle, same thing. All right, for letter C, how about we get an idea of where we are this time? I'll do this first. So negative 2, negative 4, and we're down here. We'll keep that in mind. We need the Pythagorean theorem. We need r and theta. So r is equal to the square root of 4 plus 16. That's square root of 20, and that is 2 square root of 5. All right, so we have the r. Now let's get the angle, and we know that theta is equal to, and if we took the inverse tangent of both sides, that would undo each other, and we'd have the inverse tangent of y over x. So we need the inverse tangent of negative 4 over negative 2. which is the inverse tangent of positive 2. Inverse tangent of 2 is 63 degrees, but 63 degrees is actually up here. Here's the 63. But our point's not over here, it's actually in the other direction. So the first point I'm going to write is negative 2 square root of 5 at that 63.435 degrees, rounded, or 4 if you want. But if I want to use a positive 2 square root of 5, then we're going to have to add 180 to that angle. So we're going to add 180. And that's going to be 243.434 or 435 degrees. There we go. So again, we have to know where we're at because we're going to use inverse tangent to find it. And inverse tangent uses principal quadrants. Identify the graph of each rectangular equation. Then write the equation in polar form. Support your answer by graphing the polar form of the equation. All right, well, let's do this. Let's get the polar equation and then we'll graph. Let's do that. Well, let's FOIL this out. X squared minus 8x plus 16 plus y squared is equal to 16. We can subtract 16 from both sides. And we get x squared minus 8x plus y squared is equal to 0. Well, x squared plus y squared, if we look back at our toolbox, we have that relationship right there. X squared plus y squared is r squared. So we can say x squared plus y squared. We can turn those two into r squared. And we can add the 8x over. But we also know that x is equal to r cosine. If we look back here, x is equal to r cosine. So I can change x to r cosine of theta. Well, now we can divide both sides by r, and we have r is equal to 8 cosine of theta. And we have a circle with a diameter of 8. And if we look up here, this is always the r squared. R squared is 16, so r, the radius is 4 according to this equation. But if we doubled that, that would be our diameter. And we're getting the same thing no matter what form we have. We could have rectangular, and we have a diameter of 8. We have polar, and we still have a diameter of 8. And we're going off to the right here because this is cosine. So there's a diameter of 8. 1, 2, 3, 4, 5, 6, 7. Oh, that's 1, 3, 4, 5, 6, 7. On other graphs, I had 8 circles. So let's go by 2s. 2, 4, 6, 8. Right there. And then we want to go up 4, 2, 2, 4, 2, 4. Right there. Down 2 over 2, that puts us right there. Now this also says, if you remember your conics, is that we have a center of 4, 0. Well, that's the same thing for this circle right here. There's the center, 4, 0. We have a diameter of 8, center of 4, 0, and then of course we draw this circle, something like that. All right, there we go. Write each equation in rectangular form and then identify its graph. Support your answer by graphing the polar form of the equation. Let's get the polar form of the equation and then we'll graph. All right, so here we go. What do we have? We know that, well, let's take the tangent of both sides. Tangent of theta is equal to the tangent of pi over 6. Now, why tangent? Well, if you look back at our toolbox, we need to get an x and a y in this. We need to go from polar to xy to rectangular. This says that if you have the tangent of theta, that's the same as y over x. Let's go back to our problem where we have tangent of theta, and that's the same as y over x. And we know that, let's find the tangent of pi over 6. If that was 1, let's see, it would be square root of 3 over 2, 1/2. Tangent is sine over cosine. That's 1/2 over square root of 3 over 2. 1 over square root of 3, so we know that it's square root of 3 over 3 if we rationalize. And then we multiply by x, so square root of 3 over 3x. Well, that's a line. That is a line. And it's a line along the angle pi over 6. And notice that if we go this is the slope. If we go up 1/2, so if this was all the way to 1, if we go up 1, 2, 3.5, because it's 7, at there's 7 marks. So half would be 3.5. 1, 2, 3.5. We'd have to go over the square root of 3 over 2, whatever. That's like 0.8, I believe, if I remember right. All right. Anyway, that would be the slope of the line. And then we could draw it back this way as well. So theta equals pi over 6. That's a line along the angle pi over 6. Write each equation in rectangular form and then identify its graphs. Support your answer by graphing the polar form of the equation. In rectangular form. All right, so let's do this. I have to turn everything into x's and y's. And the technique on this one is we're going to multiply both sides by r. We get r squared is equal to negative 5r sine of theta. And if you look back at the tools that we have, we see that x squared plus y squared is the same as r squared. Well, we have r squared on the left of this, so I can rewrite this as x squared plus y squared. And r sine is the same as y. R cosine is x. So let's get this is not how we write the equations of circles. This is a circle, by the way. We're going to add the 5y over here plus something. We're going to complete the square on this. And if we add 5y on this right side, we get 0, and then we got to add something to both sides of the equation. Well, to complete the square, we always take b, divide by 2, and square. So we're going to add 25 fourths. So we have 25 fourths. So this would factor into y plus 5 halves, y plus 5 halves, or y plus 5 halves squared. And there we have what we call completing the square. We have something squared now. So that's equal to 25 fourths. Well, it says, graph the polar form of it. Now we know that this is sine affects the y and it's negative. So we have a diameter of 5. 1, 2, 3, 4, 5 right there. And we need to go down 1, 2.5. There's the center. And if we go over 2.5, we get that one. Left 2.5, about right there. So there's the circle. Now, are we getting the same information from the rectangular version? Well, this says we have a center of 0, negative 5 halves. That's exactly what we have. 0, negative 5 halves is the center. And this is r squared right here. So the radius is 5 halves. And here the radius is 5 halves. Therefore, the diameter is 5. So it doesn't matter if we're graphing in polar or if we turn it to rectangular. We should be extracting the exact same information, and it should be the exact same graph. So that's a completion of 9.3. Let's get into 9.1. And the year I made this video, we were doing the Zoom sessions, and we only had a half hour. And so I've put way too many notes on this, knowing that it would take too long to get through all. I'm not going to do all these problems, but if you want a nice little review of 9.1 and 9.2, I'm going to keep going with this and just pick a couple examples and do them. So find 3 different pairs of polar coordinates that name the given point if theta is between negative 360 and 360 or negative 2 pi to 2 pi. So let's grab, how about that one right there? So radius of 1 at 150 degrees. So that's actually right here. Now this is labeled in radians, of course, but we're going to use degrees. What do I need to find? 3 different pairs. Well, I have one with the positive 1. I should be able to get another one with the positive 1 with a negative angle instead of a positive. And then I should be able to get a positive angle with a negative 1 and a negative angle with the negative 1. So you should be able to get 2 positives, 2 negatives. Now we went 150 degrees to get to this point. So if I go the other way, it's 180 plus another 30. So negative 210. That'll get us to the same point. Well, how about negative 1 over here? How can we get to that? We can get there 2 different ways. We can go negative 30. So negative 30 degrees. or we can go positive. Oh boy, we're going to have to go all the way around. Here's 270, and then another 60 would be what, 330? 330 degrees. So you should always be able to get 4 points, 4 ordered pairs for each polar point. Graph each polar equation. R equals 4. Well, that's a circle with a radius of 4. And using this tablet is just impossible to draw circles. So 1, 2, 3, 4. There we go. I get to cheat a little bit. There's R equals 4. Now with theta equals 225 degrees, that's going to graph a line. So let's go to 225 degrees. 225. That's what? That's one of the pi over 4s. So it's this line right here. And I did number 24. So these are circles. These are lines. Find the distance between each pair of points. Well, let's pick, how about number 30? Let's pick number 30. So the distance is equal to the square root of, and this is law of cosines. So we have 4, we're going to square the 2, plus square the 5, so 25, minus 2 times 2 times 5, and then the cosine of the angle, the second angle, minus the first angle. Now I left the answers on here to see if I can get the equation right, see if I can type it in right, and yeah, we'll see here. 4 plus 25 minus 2 times 5, and then cosine of, and you can let the calculator do the work if you want. Was that going to be 90? So minus, oh, I have 120. I need 120. 120. Now, you got to make sure your calculator is in degrees because we're using degrees, and then make sure your calculator is in radians when we're using radians. Press enter. 5.385. They rounded to 2 decimal places. 5.39. We got it. We're good. 5.39 rounded to 2 decimal places. Graph each equation by plotting points. Yeah, and we use the system and everything, but I'll just tell you that this is a circle. Let's take a look at r equals cosecant of theta. R is equal to cosecant of theta. Well, we know that r is equal to 1 over cosecant. The reciprocal of that is sine. So then we can multiply both sides by sine of theta. And on the left, we get r sine of theta is equal to, excuse me, and then on the right side, we get 1. R sine is the same as y. Look at the toolbox that we have for section 3. It says y equals r sine. So y equals 1. If we graph this right here in polar, and if we graph this in rectangular, that's going to be the same thing. Well, this is a horizontal line. This is a line where y is equal to 1. Where y is equal to 1. That's when you have cosecant. When you have, is there a secant example? So this is a horizontal line. This is going to be a vertical line. This is a circle, circle. This is going to be a horizontal line, circle, circle. Use symmetry to graph each equation. We have a whole process for this, but let me tell you this. This right here is going to be a cardioid because we're going to get, with our process that we use, we're going to get 0 for one of the r's. This is dimpled because there's no way you're going to get a negative, or there's no way you're going to get a 0 radius. This is a cardioid. This is also dimpled because the lowest we can go is -4, so all the r's will be positive and they won't be 0. This is an inner loop because when we take 1 minus 2, we're going to get -1. This is also an inner loop. This is an inner loop because when we take 3 minus 5, when cosine 0, we get that -2 right away. Now this one, 6 is more than twice 2. 6 is 4 or more. It's more than 4, more than double this value. So this is where we get a convex limacon. Convex. What else can we talk about? This is going to be a rows, yeah, from 0 to 2 pi, and we're going to count by pi over 8ths. This is going to graph from 0 to pi because of the odd coefficient, and we're going to count this one pi over 6s. Over here, even, so these are 0 to 2 pi, and we're going to count by pi over 4s. One other thing, now there's going to be 4 petals. This is going to be 3 petals, and each of these two right here, 18 and 20, they're going to be 4 petals for those. Anytime it's even, you double the number, and that's how many petals you have. When it's odd, it's going to be the same amount of petals as that coefficient. All right, there we go. There's 9.3. A little review of 9.1 and 9.2, and we'll see you later.